back to Let's Learn Together. I am George Yusuf. In this video tutorial, we're going to print the contents of a register. For example, a L register or a H register or the whole 16-bit register, AX. And once we have figured out a way of doing that and we have our program source code completed, then we can apply that to any other register. So let's get started. Assume we have some number in AL register. I'll say move into AL, let's say 4F hexadecimal. What we want to do is first delete the letter F and leave only 4. Print that to the screen and then come back, delete number 4, leave only F, and then print that one to the screen as well. So what we want to do is something similar to this. Move into AL, 40H, and then after that will be AL will look like 0FH, like that. So let me load that into AL. First, we're going to delete F. It's going to look like this, 40. And then the second time, we're going to delete 4 and leave F, which is going to look like that, 0F in AL. So what we're going to do is to delete the letter F from this register, which is the low nibble. F is the low nibble, and 4 is the high nibble of this register. So to delete F, or the lower nibble, we can do AND AL with 11110000H. And if you don't know what ANDing is or what it does, it's time to go to the documentation page and click on instruction set, complete 8086 instruction sets, and look for and you'll see the rules are 1 and 1 equals 1. Everything else, all other combinations is 0. So only 1 and 1 gives you 1, which is the opposite of OR, by the way. Or will do the opposite. Only 0 and 0 gives you 0. Everything else gives you 1. Just so you know that. So ending that will do what? Let's check it out. Oh, this is binary, not hexadecimal, B. So let's check that. I have 4F and AL. Once I end it, it will delete the lower nibble. Makes it 40. So what we have now is the number 4 residing at the high nibble side by itself. So in order to print that, we need to shift it to the low nibble. So we need to move it to the right side, and there are 2 ways of doing that. We can either do shift right AL by 4. That's one way. Let's check it out. Emulate, and it, and now shift right. Notice how many clicks it takes. 1, 2, 3, 4. It takes 4 clicks to shift that to the right. Let me reload again. Watch AL register as I click on it. Now this is first click, 2, 3, 4. It moved it to the right. Now we can print it. We can simply move that to DL register, add 48 to it, and print it. However, the preferred way is to move into the L register, the number 16, and then divide the L. This takes only, instead of 2 and 2 and 2 and 2 bytes, that's 8 bytes, it takes 4 bytes to do so. So move BL as 2 bytes and then divide BL, that's another 2 bytes. So it's more efficient, and there we go, we got 4 on the right side. It's more efficient and faster than shifting 4 times. Okay, note that when we end this AL register, if we zero the low byte or the low nibble, I'm sorry, we'll be left with 40. And we divide by 16 only for the high nibble, right? Because there's a 0 in front of it on the right side. When we process the other side, when we do the letter F, delete 4 and leave F, we don't have to divide by 16 anymore. We can just move that into DL, or first check if it's a number from 0 to 9 or if it's a letter from A to F. Based on whatever it is, a number or a letter, we move it to DL, convert it to Ascii by adding either 48 or 55 to it, and then use service 2 of interrupt 21 to print it out to the screen. So let's create a label over here, and we'll call it high nibble. So I'm doing this because later we'll do a whole register. Instead of AL, we'll do AX. So we'll have two registers to do that. So we'll have high nibble and low nibble for AL, and then high nibble, low nibble for AH. So what does processing high nibble take? We'll divide it. And now we have 4 shifted to the right. We can compare that now to 10. Compare AL with number 10, which is letter A. And if it's less than 10, which is 0 to 9, then it's a number. So we'll say jump it below. What I'm saying is jump if destination, AL, is below 10. Jump if below to a number. Jump to this label, number. Otherwise, if it's not, jump to letter. So we need to create 2 labels that will process a number and another label that will process a letter, how to print a letter, right? So let's create 2 labels for now. We'll call the first one number, and I'll say NOP for no operation for now, just to have them there. And a second one will be letter, and also NOP. And let's single step through it to see how far we get. I'll load 4F into AL, and it, and then move 16 into BL, which is 10 hexadecimal, 10. Divide BL by AL, that gives me 4 in AL now. Now I'll compare it to 10, and I'll say jump if below, which in this case it is below, it should jump to number, and it does. So we're gonna have to process that number. If on the other hand, let's swap these numbers. I'll say F4 instead, or F3, that works too. Emulate. Oh, I gotta put a 0 in front of it. Okay. Let's do single step. Compare 10 to AL. Jump up below, it's not below, so it's gonna keep going. Otherwise, if it's not, then it has to be from A to F, so jump to letter. So we'll jump to letter. So now let's take care of these 2 labels. Let's say number. What happens when it comes here? We want to move that value in AL to DL. Move to DL, whatever is in AL. And then if it's a number, we need to add to DL 48. Or remember, we can also do add to DL 0 in quotes. That's ASCII 0, or 48 is the same thing. So once we add to it that, we can now move into edge 0 to edge, into 21 edge to print it, and we can return. Now on the other hand, with letter, it's going to be almost same thing. Move into DLAL and then add to DL number 55 this time. Move into a edge 02 and then interrupt 21 edge and return. So in case you don't know why 55 or 48 we're adding, just go to the ASCII code. Let's assume it's letter A, which is 10, number 10 over here. And notice number A is 65. If you add 55 to 10, it becomes 65. It converts it to a letter A. If you have 11, which is B, if you add 55 to it, it becomes 66, letter B, and so on. So now let's step through this program really quick. I'm just going to change this back to 4F and emulate. We'll see what we print first. So I'm going to load that into AL, and it divide by 16. Now we'll compare. Is it a number? For now it is. It's going to jump to number. Move that into DL. Add to it. Becomes 34. And move to into AH, enter up 21, print it. Okay, and return. Well, it's not going to return now because it was not called for. It was a jump. Was it a jump? Yeah, it was a jump. It's not going to get back. We'll fix that. So to fix that problem of not returning back, what we could do is we'll say over here call high nibble. Okay, what we'll do, and it will jump over here, and then it gets to one of these options. It's going to print and return either or, number or letter. Whatever it prints, it returns to this location. I'm going to say NOP for now, no operation, but we'll add to it. Let's test it. I'm going to single click through it fast, just so we can see. Now it prints the first number and returns to that location where we left off. So now that we printed the first one, we need to process the low nibble. So notice what happens to AX register. I don't know if you did or not. Let's single step through it really quick. Wait there. We had 4 in AL. Once we got to this point, we moved 2 into AH. Ended up 21 will destroy AX register. Now AX has different value, 234. We lost the value of 4F. So before we do call high nibble, we need to save AX register. And we do that by pushing it to the stack. So we can do push AX, that pushes it to the stack. And once we're back, at this point, we'll say pop AX. So let's check that out. I'm gonna go single click fast through it, return, pop AX, and we brought 4F back. Now we can process the low nibble. And since low nibble processing involves comparing with 10, same as what we have here, and jump accordingly, we don't need to divide by 16. All we have to do is create a label over here, and we'll call it low nibble. And we can jump to low nibble right there. But we have to end it first. So I'm going to end AL with the opposite of what we did the first time. And then call low nibble. And once it's done, it comes back. I'm going to say jump to end. Okay. What happens is the first time it processes the high nibble, it comes to this point, divides by 16, and it continues downward. The second time, we'll skip this portion of the instructions. We'll skip all the way to low nibble. So it directly comes to this point, compares it to 10, and jumps based on whether it's a number or a letter. So let me emulate and run it this time. Here we go, 4F is printed. So what I would like to do now is to do the whole AX register, to print the value of AX register, not just AL. I want to do the whole 16-bit value of AX register, which will be 4 nibbles. But since we're running out of time, we'll have to split this video into two parts. So in the next part, we'll take care of that. And once we have that figured out, you can apply that to any register or a combination of registers. And if you enjoyed this video, please take a moment to like and subscribe. Maybe share or comment or post some questions that you might have to help this channel. And hope to see you soon in the next one. So goodbye now.